So the next topic is calculation of small g. Okay, so now let's start the derivation. So according to Newton's second law, F is equal to mass times the acceleration. So in this case, acceleration will be equal to acceleration due to gravity. And according to the universal law of gravitation, F is equal to g m by d square. Okay, so from this, so the two equation can be equated, right? Because the two forces are equal in this case. So what we are going to do is, so let us consider this as equation 1 and this as equation number 2. So now 1 is equal to 2. Okay, so what will happen? The first equation is mg and the second equation is gmm by d square. So this m and this m will get cancelled. So g is equal to gm by d square. So where g stands for acceleration due to gravity, we can write like this. G stands for acceleration due to gravity, and capital G stands for universal gravitational constant. Okay, and m represents the mass of the earth. Okay, mass of the earth, and d represents the distance of the earth from the moon. So this is all about the derivation of g. Okay, so it is a very easy derivation. Okay, so you have to take the first that is Newton's second law derivation and universal law of gravitation, and finally you have to equate it and to find the value of g, and g is equal to gm by d square. So g and d are inversely proportional to each other, correct? So g and d are inversely proportional to each other, which means if the distance between the planet is less, the gravitation will be more. If the distance between the planets is more, the gravitation will be less. So it is vice versa. Okay, and so g stands for acceleration due to gravity, capital G, that is universal gravitational constant, and the value is 6.67 into 10 to the power minus 11 nm square kg minus 2. In this case, we took the acceleration due to gravity of the earth, so it is 9.8. It is approximately 9.8 meter per second square. And mass of the earth, as we already know, it is, what is it? 6 into 10 to the power 24 kg. So these are the known datas. And also, instead of instead of d, in certain cases we will be taking the distance as the radius of the earth. So the formula will be g is equal to, in certain cases we will be taking this formula also. So g is equal to gm by r square. So r square is nothing but radius of the earth, and the value is 6.4 into 10 to the power 6 meter. Okay, on substituting all these values, now you will be getting the answer for g as 9.8 meter per second square. For that also we will have one see. So g is equal to, what is that, 6.67. Capital G is 6.67, right? So 6.67 into 10 to the power minus 11 into 6 into 10 to the power 24 kg, that is mass of the earth, by 6.4 into 10 to the power 6 meter, the whole square, since r square means whole square. On substituting all these values, the final answer will be 9.8 meter per second square. So this is the value of g. So the calculation of g is also done, and we also calculated by using these values, substituting these values, and finally we got the answer. So when you multiply these two terms and you add the powers, since the base terms are equal, 24 minus 11, and solve this square belongs to two terms inside. So 6.4 into 6.4 into 10 to the power 12. So when this 10 to the power 12 goes up, it becomes 10 to the power minus 12. So you work out it, you'll get the answer as 9.765, like that it will be getting the answer. So you have to round it off So round it off to 9.8 meter per second square. So the acceleration due to gravity of the earth is 9.8 meter per second square. So keep the formula in mind as F is equal to m times g, and universal gravitational constant is g, and the formula will be like F is equal to gmm by d square. So these are the formulas and these are the derivation for this calculation of g. Okay, so thank you, hope you got clarity.